In example 6, you're going to find the domain of each function. So let's look at part A. At part A, we have a radical. It says f of x is equal to the square root of x plus 2. So this index is even. And since it's an even index, that means that we cannot take the square root of a negative number. So for that tells us that the only thing that can be under the radical is anything that is equal to 0 or above. So that means we need to take x plus 2 and set the inequality to be greater than or equal to 0 and then solve for x. So in order for us to solve for x, we're going to subtract 2 to both sides. So we know that x is going to be greater than or equal to negative 2. So now we want to then graph this on our number line. And so if this is located at 0 and this is negative 2, then what do we know? We know that we have a bracket here at negative 2 going all the way towards positive infinity. So therefore, in step 3, what is the domain of this function? Well, the domain is either the set builder notation where we would say that x such that x is greater than or equal to negative 2, or we can write this in interval notation, which means that we have negative 2 going towards infinity. Okay, for part B, we want to find the domain of this function. So how do we find the domain of this function? Well, just recall that if we have a variable in the denominator, we got to make sure at what point or points or values is it going to be undefined. So in order for us to do that, in step 1, we know that it cannot equal 0, but it has to be either not equal to 0. So we know if it's not equal to 0, we're going to take x squared minus x and find out when it does not equal 0. So what we can do is we can factor out an x, and what's left is x minus 1, and that means it cannot equal 0. So that means we know that one of the x's cannot equal 0, or we know that x minus 1 cannot equal 0. So now, by solving for x, we know that x cannot equal 0, or it cannot equal positive 1. Now, the next thing we want to do is, it's not necessary, but it's nice to see a clear picture when you have a graph. So, let's graph the number line here. And let's put in the values that we just solved. We have 0, and then we have a positive 1. So, we know that there is these regions that we've created. We know we have negative infinity and we have positive infinity on this side. So what does that tell us? That tells us that we can choose any number from negative infinity all the way to 0, but we cannot include in 0, so we need a parenthesis. But then we need to keep going, so we have a parenthesis here, and then going all the way to 1, but we cannot include 1, so we have a parenthesis. And then we have another parenthesis at 1, and then we're going all the way to positive infinity. So what does that tell us? Well, that tells us the following. That means that we can write this in two forms. We can say that the domain is that x such that x cannot equal 0 or negative 1, or we can write this in set builder notation. In interval notation. So we know that we're going from negative infinity to 0, parenthesis, union, 0 to 1, parenthesis, union, and then 1 to infinity.